Hello, chemistry students. Here are the corrections for page 186, 24 through 28, your homework assignment. Number 24 says, find the mass in grams of each quantity. So, again, these are sort of story problems. So this first one is asking me to take 0.720 moles of beryllium and figure out how many grams of beryllium that is. So the question is, do I have a tool on my toolkit that has moles and grams in it? And you do, right? It's called molar mass. So I'm going to start with my given, 0.720 moles of beryllium. Because moles are in the numerator, I have to put moles of beryllium on the bottom. And I'm going to put grams of beryllium on the top. The name of this conversion factor is molar mass. And again, we can see that we're going to be in the right units because we're in grams of beryllium. So again, when you look at your toolkit, the unit in front of molar mass, or units for molar mass in front of moles, are always 1. The number for grams comes from your periodic table. So again, you're going to look at your periodic table, find beryllium, and find its mass, which is 9.0122. Make sure you use at least 3 significant figures because 0.720 has 3. And I should multiply those numbers. So 0.720 times 9.0122. Okay, so my calculator gives me 6.488784 grams of beryllium. But remember, I have to pay attention to significant figures now. So this first number has 3 sig figs. I made sure here that I have at least 3 sig figs, so my answer should have 3 significant figures. So the correct way to report my answer would be 6.49 grams of beryllium. Again, as long as you're close, that's fine, right? If you have 6.50 or 6.48, that's close enough. All right, looking at letter B. This one is asking me to take 2.40 moles of nitrogen gas and figure out how many grams of nitrogen gas I have. Again, I have a tool that has moles and grams in it. It's my molar mass. So again, I'm going to start with my given, which is the 2.40 moles of nitrogen. Moles of nitrogen have to go on the bottom, so they'll cross out. I'm going to do grams of nitrogen on the top. Again, the name of this conversion factor is molar mass. And in molar mass on your chemistry toolkit, your index card, again, it's a 1 that goes in front of moles. Now, because there are 2 nitrogens here, I have to do 2 times the molar mass of nitrogen. And nitrogen's molar mass on my periodic table is 14.007. So that is 28.014. Moles of nitrogen are crossing out. I'm left with grams. So again, I'm multiplying because both those numbers are in the numerator. So times 2.4. And again, my calculator gives me 67.2336 grams of nitrogen. Again, I have 3 significant figures here, okay? And I have, really, the way I wrote it was 5 significant figures. So I need to have 3 significant figures here. So my answer with 3 significant figures should be reported as 67.2 grams of nitrogen. All right, let's look at letter C and D. C is asking us to take 0.160 moles of hydrogen peroxide and figure out how many grams of hydrogen peroxide we have. Again, we have a tool on our toolkit that has grams and moles in it. It's molar mass. So again, I start with my given, 0.160 moles of peroxide. Moles of peroxide have to be on the bottom. Grams of peroxide go on the top. Again, my moles are going to cross out. I'm going to be left with grams, which is what I want. Again, this is my molar mass. So in front of moles is always 1, and my number that goes in front of grams comes from adding up numbers on the periodic table. So there's 2 hydrogens, so it's 2 times 1.0079, plus there's 2 oxygens, so plus 2 times 15.999, and so I get 34.0138. And again, I should multiply because both numbers are in the numerator. So again, my calculator gives me 5.442208 grams of peroxide. Looking at significant figures, I have 3 sig figs and 1, 2, 3, 4, 5, 6. I did 6 sig figs here. So my answer can have 3 sig figs, right? And we need to make sure this number here has at least 3. So my answer, correctly rounded with 3 significant figures, would be 5.44 grams of peroxide. Letter D. 5.08 moles of calcium nitrate equals how many grams of calcium nitrate? Again, I'm going to use that same molar mass conversion factor. So I'm going to start with my moles of calcium nitrate. Okay. Moles of calcium nitrate go on the bottom. And I'm going to use my molar mass to convert that to grams of calcium nitrate. Moles are going to cross out. Again, this is my molar mass conversion factor. And in that molar mass conversion factor, the number that goes in front of moles is always 1. Now for this, remember you don't have to show your work for calculating molar mass, but there's 1 calcium. For nitrogen, there are 2 nitrogens, and for oxygen, there are 6. Okay, so again, calcium's number on the periodic table is 40.078. Okay, nitrogen is 14.007. And oxygen is 15.999, right? I'm going to add those all together, and that's what's going to go there for my mass. So, doing that math, 40.078 plus 2 times 14.007 plus 6 times 15.999, and I get 164.086. Again, I want to make sure I use at least 3 significant figures there. So again, I'm going to multiply because those numbers are both in the numerator. And again, my calculator gives me 833.55688, okay, grams. So again, in terms of significant figures, I have 3 sig figs. I have 6 the way I wrote that, so I want 3 significant figures here. So I'm going to round this as 834 grams of calcium nitrate. So again, what all of these problems had in common was they used molar mass, and because you were starting with moles in all of them, moles were on the bottom of your conversion factor and grams were in the top. 25. Letter A, calculate the number of molecules in 60 grams of NO2. So this one is asking me to take 60 grams of NO2 and figure out how many molecules, okay, of NO2 that is. So the first thing is I don't have a tool that has grams and molecules in it, just one single one, which tells you that you're going to have to use multiple conversion factors to do this one, right? The conversion factor that has grams in it okay, is going to allow you to go to moles, and the one that has molecules in it is going to be moles as well. Okay, so we're going to have to do two conversion factors here. So again, we're going to start with our 60 grams of nitrogen dioxide. Grams of nitrogen dioxide have to go on the bottom because they're in the top here. And we're going to convert that to moles of nitrogen dioxide. Now I can't stop because I'm in moles and I want molecules. So moles of nitrogen dioxide go on the bottom. Molecules of nitrogen dioxide go on the top. So now I will be in molecules, so I know that I'm kind of going to be done doing my problem. In terms of numbers, remember this is our molar mass conversion factor. So the easy number in there is the 1 that goes in front of moles. To get the number for the molar mass for nitrogen and oxygen, I have 1 nitrogen and I have 2 oxygens. And again, nitrogen's mass from the periodic table is 14.007. For oxygen, it's 15.999. Okay, and then I'm going to add those two together, and that's going to be my molar mass. So 14.007 plus 2 times 15.999, and I get 46.005. I want to use at least 3 sig figs, so you could just write it as 46.0. That would be fine. Now, this is our count conversion factor that involves Avogadro's number. So again, the easy number is the 1 that goes in front of moles. The number that goes in front of molecules is 6.022 times 10 to the 23rd power. Now, again, this is one of those ones where you need to make sure you understand whether you're multiplying or dividing, right? I'm going to multiply, okay, by things that are in my numerator, and I'm going to divide by things that are in my denominator. So when I type this in my calculator, I'm going to type 60 times 6.022, I'm going to use that E button so I don't have to worry about parentheses, 23, divided by the 46.005. So, and I need parentheses just to make sure my calculator does it the right way. And again, here's what my calculator gives me. Okay, so it gives me a big long number, 7.853928921 times 10 to the 23rd molecules of NO2. Now I need to look at significant figures, right? I have 2 sig figs. I need to make sure I have at least 2 sig figs here. I have at least 2 sig figs here. Really, I have 2 sig figs plus. So my answer can have 2 significant figures. So, or sorry, I said 2, but it's 3. 60.0 has 3 because all of them are significant. So I want 3 and I want 3 at least here. So my answer should have 3 significant figures. So again, that's going to make it 7.85 times 10 to the 23rd molecules of nitrogen dioxide. Okay, so again, that is your final answer for that one. Remember, you do not need to show me this work. You don't need to show me this work. I'm showing it here so that if that's where you're struggling, you can see where I get those numbers from. So letter B asks you to calculate the volume in liters of 3.24 times 10 to the 22nd molecules of chlorine STP, and it's at STP. So again, this problem is asking me to take 3.24 times 10 to the 22nd molecules of chlorine, and figure out how many liters of chlorine that is. Again, I don't have one single conversion factor that has both molecules and liters in it. My one with molecules has moles in it, and my one with liters in it has moles in it. To use the liter and mole one, I have to be at STP, which is why they have STP in parentheses. So this is going to require multiple conversion factors. I still start with my given. Because molecules of chlorine are in the numerator, they're going to go in the denominator now. I can convert molecules to moles. That's the other unit in that tool. I can't stop because I'm in moles and I want liters. So I do have a tool that has moles and liters in it. So moles of chlorine to liters of chlorine. And that's going to leave me with the answer in the units I want. Now again, this is my count conversion factor that uses Avogadro's number. So again, the easy number is always the number that goes in front of moles because it's 1. And in front of molecules, it's 6.022 times 10 to the 23rd power. Again, this conversion factor is molar volume. And again, the easy number is the 1 that goes in front of moles, and in front of liters, it's 22.4. Again now, should I multiply or divide, right? So when I put this in my calculator, I'm going to do 3.24 E22 times 22.4, close my parentheses, divide by 6.022 E23. Okay, so 3.24 E22 times 22.4 divided by 6.022 E23. Okay, and again, my calculator gives me, okay, 1.205181003 liters of chlorine. Significant figures. I have 3 sig figs because remember when I write something in scientific notation, every number of the coefficient is significant. So I have 4 sig figs here, and I have 3 sig figs here. So my answer can have 3 significant figures because when I multiply and divide, I'm limited by the number that has the fewest. So I'm going to write this as 1.21 liters of chlorine. Letter C. Calculate the mass in grams of 18 liters of methane at STP. So in this one, I'm asked to start with my 18 liters of methane and figure out the mass in grams of methane. Again, same thing here. I don't have one tool that has both liters and grams in it. My one with liters has moles and requires that it's STP, which is why we have STP written here. And my one with grams in it has moles in it. So again, that means that this is going to require multiple conversion factors. I still start with my given, which is the 18 liters of methane. Liters of methane have to go on the bottom. And the tool I have is molar volume. And the other unit in molar volume is moles of the same substance. I can't stop. I'm in moles right now and I want grams. So moles of methane have to go on the bottom. Grams of methane is going to go on the top. I can stop now because I'm going to be in the correct unit. This one is our molar mass conversion factor. So now numbers, right? Easy numbers are moles because the numbers in front of moles are always 1. In front of liters on molar volume on your chemistry toolkit, right, the number in front of it is 22.4. The number that goes here, right, that comes from adding things up on our periodic table. So we have carbon and hydrogen, 1 carbon, 4 hydrogens. Remember, this is not work you have to show me. I'm just showing it to you for the people that are struggling so that they can see where these numbers come from. 12.011 is the mass of carbon from the periodic table. Hydrogen is 1.0079. I'm going to multiply those and then add those two answers together. Okay, so 12.011 plus 4 times 1.0079, and I get 16.0426. So again, calculator wise, right, I'm going to take 18, multiply it by 16.0426, and I'm going to take that answer and divide it by 22.4. And again, my calculator gives me 12.891375, okay, grams of methane. Now, in terms of significant figures, I have 3 sig figs here. I have 3 sig figs here. And I have 1, 2, 3, 4, 5. I did have 6 sig figs here. So my answer can only have 3 significant figures. So to rewrite my answer with 3 significant figures, it's 12.9 grams of methane. 26. Would 3 balloons, each containing the same number of molecules of a different gas at STP, have the same mass or the same volume? Explain. So 3 balloons, each containing the same number. So here's balloon. Here's a balloon. And remember, I'm not very good at drawing, but I think you can tell they're balloons at least. Now, same number of molecules. So I'm going to purposely choose to put 1 mole of molecules in here. Which means I'm going to have 6.022 times 10 to the 23rd particles in every balloon, right? Because that's what it means to have a mole. Now, we say they're different gases, so let's just kind of pick some gases. Let's make them easy gases. Let's make it hydrogen. Let's make it helium. And let's make it neon gas. Okay, so because we have 1 mole, right, we can talk about what the molar mass of each of these substances is. So hydrogen's molar mass is 2 times 1.0079. So the mass of this balloon would be 2.0158 grams, right? Because I have 1 mole, and the molar mass is 2.0158 grams per 1 mole for hydrogen. Okay, and I'm going to do the same kind of thing for each of these, okay? So for helium, it's just going to be 4.0026 grams. This is just 1 helium atom. And for neon, it's going to be 20.180 grams because there's just a single atom in there. Okay? Now, the question is, they each have the same number of molecules, which we made sure, right? With this, right? They have the same number of molecules. They're different gases, right? We made sure of that with this, right? We have hydrogen, we have helium, we have neon. Do they have the same mass or the same volume? Explain. So first off, the volume or the mass part of this, right? So the mass part of this here's one mass, here's the other mass, here's the other mass. So is their mass the same? The mass is not the same. The second part of that question, right, has to do with, okay, the volume. Now, again, purposely, because we chose 1 mole, remember that means that this has a volume of 22.4 liters at STP. And it's 1 mole in all of them, which means the volumes of all of the balloons would be the same. So, do they have the same volume? The volume is the same because all the balloons contain the same number of molecules. Therefore, they have the same volume. So what stays the same? It's the volume. 27, find the number of moles in each quantity. So letter A, 5 grams, and here's where you have to be careful. This says molecules, which means it means H2. And we want to know how many moles of H2 that is. Again, I have a tool that has grams and moles in it. It's molar mass, so it's just going to require 1 conversion factor. Grams of hydrogen have to go on the bottom. Moles of hydrogen go on the top. We actually just did this, right? That was 2.0158. So 1 mole is 2.0158, okay, from adding up 2 hydrogens. Now, this time, right, we should divide. And again, my calculator gives me 2.4804044802 moles of hydrogen. In terms of significant figures, I have 3 sig figs here. I have 2 5 sig figs here. So my answer can have 3 sig figs, right? And I want to make sure here that I use at least 3 significant figures. So my answer with 3 significant figures would be 2.48 moles of hydrogen. Okay. Again, if you get 2.49, if you get 2.50, if you get 2.51, that's all fine. And this conversion factor, remember, by the way, was our molar mass conversion factor. Letter B, 0.000264 grams of lithium hydrogen phosphate equals how many moles of lithium hydrogen phosphate. I'm still going to use molar mass. I'm just going to write compound. And grams of compound have to go on the bottom. Moles of compound have to go on the top so that they will cross out correctly. I want moles of compound, so that's good. Again, this is my molar mass. So it's 1 in front of moles. To get my mass, I'm going to have quite a bit of math to do here because I have 2 lithiums. So 2 times 6.941 plus a hydrogen, 1.0079, plus a phosphorus, which is 30.974, plus 4 hydrogens, so 4 times 15.999, and I get a mass here of 109.85 100.599. Again, as long as I use 3 significant figures, that's fine. So I could call it 110 with a decimal. Again, I should divide here. So I'm going to take 0.000264 and divide it by that mass I just figured out. Okay. This is probably one where I'm going to express my answer in scientific notation. Okay. So again, I'm going to go ahead and just do significant figures. So I have 3 sig figs, and I have 3, 6, 7 sig figs. So my answer can have 3 sig figs. So I get 2.403060625 times 10 to the negative 6. So that's going to be 2.40 times 10 to the negative 6 moles of lithium hydrogen phosphate. Letter C. Okay. 187 grams of aluminum. Well, we want to know how many moles of aluminum that is. Again, I'm going to use my molar mass. Grams of aluminum have to go on the bottom, so they'll cross out. Moles of aluminum go on the top because my conversion factor here is molar mass. And the other unit in molar mass besides grams is moles. The easy number is the one in front of moles. For grams, I'm going to look up the mass of aluminum from my periodic table, so 26.982. I should divide here. So 187 divided by 26.982. And again, significant figures, 3 sig figs and 5 sig figs, so my answer can have 3 sig figs. So I'm going to write it as 6.93 moles of aluminum. Again, as long as you're close, you're good. Letter D. 333 grams of tin 2 fluoride is how many moles of tin 2 fluoride? So again, I start with my given 333 grams of tin 2 fluoride. I'm going to use molar mass to convert grams of tin 2 fluoride to moles of tin 2 fluoride. Easy numbers, 1 in front of moles. For tin 2 fluoride, it's 1 tin, and tin's mass on our periodic table is 118.71, plus 2 times fluorine's, which is 18.998. So I get 156.706. Again, I should divide. And I have 3 sig figs and I have 6 sig figs, so my answer should have 3 significant figures. So I get 2.12 moles of tin 2 fluoride. #28. The densities of gases A, B, and C are 1.25 grams per liter, 2.86 grams per liter, and 0.714 grams per liter, respectively. Calculate the molar mass of each substance. Identify each substance as ammonia, sulfur dioxide, chlorine, nitrogen, or methane. So I have gas A, which has 1.25 grams per liter. I have gas B, which is 2.86 grams per liter. And I have gas C, which is 0.714 grams per liter. In all of these, I have grams per liter, and I'm trying to get it into the molar mass, which is grams per mole. So, only thing I need to change is liters to moles, and I have a tool that has liters and moles in it. To use it, I have to be STP, so I'm just going to say it's STP. So I'm changing liters to moles. So liters need to go on the top, so they'll cross off. Moles go on the bottom. 1 mole is 22.4 liters. So to do the same thing every time here, liters have to be on the top, moles have to be on the bottom. 1 mole is 22.4 liters. Liters, moles, 1 mole, 22.4 liters. So doing my math, this time I'm multiplying every time, right? Because both my numbers are in the top. So I have 28.0, and I want to use 3 sig figs, grams per mole for A. I have, with 3 sig figs, 64.1 grams per mole for B. And with 3 sig figs, I have 16.0 grams per mole because it's 15.9936. Now, I want to identify each substance as these. So for these substances, I need to calculate their molar masses. Right? And so as long as I have the formulas, I'm just going to add up the masses for my periodic table. I'm going to go ahead and just use 3 significant figures. So it's going to be for nitrogen 14.0 plus 3 times hydrogen is 1.01. So that gives me 17.0 grams per mole for ammonia. For sulfur dioxide, for sulfur it's 32.1. And there's just one sulfur plus 2 times 16.0. And I get 64.1 grams per mole for sulfur dioxide. For chlorine, there's 2 chlorines at 35.5 each. So that's 71.0 grams per mole. For nitrogen, there's 2 times 14.0, so that's 28 grams per mole. And for methane, there's 1 carbon at 12.0 plus 4 times the hydrogen, which is 1.01, and I get 16.1 grams per mole. So now the question is, which substance is which, right? So 28.0 grams per mole, 28.0 grams per mole. This is nitrogen. (64.1 grams per mole, 64.1 grams per mole. This is sulfur dioxide. And lastly, 16 grams per mole, 16 grams per mole. This is methane. So I hope that helps if you had some questions about how to do this homework. Have a great day. I'll talk to you tomorrow.